Hello, so in this video I'm gonna show you how to cast a garden trowel from cast iron. So I hope you will enjoy it. So that's the template, just a piece of steel, commercially available garden trowel. I put that here in the casting sand, fill the cope and the flask with a oil-bound casting sand I typically use, and compress that sand, and you see here got already a good impression of that trowel. So next step is just to ensure that there are no cavities or any holes, so that we get a smooth surface. And after that I'm gonna attach or make the riser and some air channels in order to help vent the mold. Yeah, so like I said, I'm gonna attach the riser. It's 5/8 of an inch. I'm gonna do it like that. And dig out a channel. That went just about right. So you want to break all the sharp edges. Like so. Don't be shy of adding some features that and help the flow distribution of that metal. So you can do, for example, add some like a fishbone pattern. So here we see the final pattern, the sprue for filling in the liquid iron, which is gonna flow through the handle and distribute through that fishbone part into the cavity of the mold. And at the fins I attached some risers in order to have ventilation of the mold. Here we see our first result. So this is the blade cast from cast iron. You can easily see how the metal flowed through that fishbone part, filling out the cavity. See the flow lines. There is a minor fault on that side, also on the other side, but it appeared to be just superficial. It did not went through the metal, so I decided to continue with that cast. Yeah, so I was able to cast this iron blade for the trowel, and so I can only stress the fact, so that is cast iron, right? So that is known to be a brittle material, but since it's white cast iron, you can do a heat treatment of that iron, and by this annealing, by this annealing process, you can convert the cast iron, the white cast iron, which is essentially a crystal. So it's iron carbide, so quite a brittle material, very hard. But when you heat treat it, when you keep it at 1500, 1600 Fahrenheit, or which translate to about 800, 900 centigrades, then you can decompose this crystal structure into iron and carbon, and that makes the material, it converts essentially to malleable cast iron, and as the name suggests, that is less brittle. So this is essentially what I'm showing you here. So I put that blade back into the induction coil with sand as insulation, and after several hours of induction, the whole blade was glowing red hot, and it just stayed that way. And I kept it at that temperature for about 2 days, and this resulted in a conversion of the iron carbide inside the white cast iron to malleable cast iron. So I'm gonna try to fish it out. Here we go. So I put both blades inside just for comparison. That's the original one, and that's our cast iron blade. Yeah, here we are about 40 hours later. So the heat treatment took about 40 hours. We left that blade at 1500 degrees for 40 hours. So inside that coil here, insulated by the sand. So that should have been sufficient in order to convert brittle white cast iron into less brittle black hard malleable cast iron, and give that blade additional toughness and minor flexibility. So the only thing that remains now is to attach this blade to its handle. Yeah, I'm quite nervous. So if that got converted to malleable cast iron, it should survive a fall on the hard concrete floor in my workshop. If it's still white cast iron, it's gonna shatter in 1,000 pieces. So I'm gonna test it. Yeah, so see you next time. Yeah, so nothing serious happened. So some of that scaling broke off, but the metal itself is still well in shape, so no cracks. So looks like a success story.